Hi, this is your math coach, Howie Tutman, presenting What Math Should My First Grader Know? I've recorded videos in the four domains or groupings of standards in math for first grade. This video is the eighth of 10 videos in the Operations and Algebraic Thinking grouping. This video is about adding within 20. This is the second part of a three-part video. If you have any questions or comments, please email me at hrtutman@gmail.com. The complete text of the standard that this video is based upon follows at the end of the video. Now we're continuing to look at the same standard as the previous video, but for larger numbers. By the end of this video, just like the previous video, I'll show lots of different addition strategies for the first graders to use. Although some of the strategies may seem confusing at first, especially if you've never seen them before, they're to provide the first graders with tools in their toolbox so they'll be able to solve problems efficiently. Sure, students could use the counting on strategy to try to solve all of their addition problems. This might work for many problems now, but it will be very time-consuming, and their answers may be prone to mistakes if they're counting on for many numbers. All first graders are in a different place in their learning, and each student progresses at a different pace. If a first grader is counting on for all of their problems, they may feel comfortable doing this, but we have to make sure that they're introduced to the many other strategies. It may take some time for you and for them to embrace all of these strategies, but once comfortable with them, problems will be able to be solved much more efficiently with significantly fewer errors, and the first graders will gain much confidence in themselves. So now we'll look at adding numbers within 20, and these numbers, their sum will be 11 through 20. So I didn't put adding 0 as one of the strategies up here, but adding 0 would be the same strategy as we used in the previous video. So 10 plus 0 is going to be equal to 10. So for these larger numbers, like 12 plus 0, 14 plus 0, they all will be equal to the number themselves. And same thing when the numbers are reversed. If it's 0 plus 12, our first grader can think of it as 12 plus 0. So they're not counting on from 0 and adding 12. They'll just start at 12. They know they're not going to be adding anything. So 12 plus 0 would be equal to 12. And then the counting on strategy, that's the same as what we looked at before. If we're looking at adding 1 or 2 to a number, the students can just count on. So if we have 10 plus 1, that's going to be equal to 11. 9 plus 2 would be 11. The example I have here is 10 plus 2. We want students eventually just to know right off that that's going to be equal to 12. But at first, a student might need to put a couple of dots here above the 2 so they can see that they're going to add on 10, 11, 12. Same thing if they see 2 plus 10, they want to think of starting with the 10, starting with the larger number, and then they're going to count on 2 more, and it'll be 11, 12. And for some of the larger numbers not shown here, the strategy will be the exact same thing. So if it's 14 plus 2, the first graders will just count on, starting with 14, and in their minds it'll be 15, 16. 18 plus 1, simply be 18, count on 1, and the answer will be 19. Moving along with a couple of the same strategies that we used in the last video, we have doubles. So that would be in these larger numbers, 6 through 10, 6 plus 6 is 12, 8 plus 8 is 16, using our double strategies for our students to learn those sums, and then doubles plus 1. And the example that I have here is 8 plus 9. And 8 plus 9 would be the same as we would be looking at. Our first grader can be thinking of this as 8 plus 8, and then adding 1 more. Same as when it's 9 plus 8. The 9 gets broken up into 8 and 1. So 8 plus 8 are our doubles that we add together, and we add 1 more for the sum of 17. Next, our first graders need to know what the sum is when they're adding a single digit number to 10. So 10 in this column here would be 10 plus 1, 10 plus all of our single digits up to actually 10 plus 10, which would be 20. So if students need a visual, for instance, 10 plus 6 or 6 plus 10, but once again, they should think of the 6 plus 10 as 10 plus 6. They have one full 10 frame. That's the yellow counters. And then for the 6, we have these 6 single red counters. So they can see that they have 1 10 and 6 ones. And that's exactly what we have here. We have our 1 10 and our 6 ones. So students need to recognize when they're adding 10 plus a single digit number, the 1 stays the same in the tens place, and this single digit stays the same in the ones place. So knowing these facts will be very important as part of our next strategy. This next strategy combines making a 10 and adding to a 10. So looking at an example here of 9 plus 6, what we'd like our first graders to do, and actually we can be looking at a 10 frame first. We can be looking at 9 yellows, 6 reds, and we want to make a 10. So we need one more counter to make a 10. So if we take 1 from this 6 and fill up the 10 frame, now we have 1 10 and 5 ones. And that's just what I'm showing here. We're breaking up the 6 to be 1 plus 5 because we know we need one more to add to 9 to make 10. So 9 plus 1 equals 10 plus 5 more equals 15. And this strategy can be used for any of these numbers here. So for instance, if we had 8 plus 5, or 5 plus 8, but we would think of it as 8 plus 5, we would take that larger number and say to ourselves, we'd want our first grader to say 8 plus how many more to make a 10 or to fill up a 10 frame? And that would be 2 more. And if it was 8 plus 5, we would break the 5 into 2 plus 3. So 8 plus 2 would make 10. And then by knowing our adding to 10, 10 plus 3 more would be equal to 13. So this compose to make 10, once again, is using our strategies of knowing the combinations, all the different combinations to make 10, which I had said in the last video is so important. And then we combine that strategy with knowing adding to 10. The final strategy that I'm going to review is decomposing to make a 10. So decomposing is just the opposite of composing. Composing means we're putting together. So in other words, when we're composing to make a 10, we were putting together, for instance, in this example, 9 plus 1 to make a 10. Decomposing means we're breaking apart. So in this case here, for instance, the number 12, we're breaking it apart to make a 10 plus something else. So in decomposing to make a 10, we'll be using the add-ins or the numbers that we're adding. It'll be a single digit number and a 2-digit number. So we don't necessarily see those numbers on this chart here, but if we have a two-digit number, the two-digit number can be anywhere from, say, 11 to 19, and we're going to be adding a single-digit number. What we'd like to do is break apart that two-digit number so that it's a 10 plus some single-digit number. So for instance, if we have 12 plus 5 or 5 plus 12, we'd want to set it up as 12 plus 5, and the 12 we'd want to break apart to a 10, and then our first grader needs to know, okay, how many ones are there? Well, this 12 represents one 10 and two ones. So we break this up to 10 and 2. And now what we want to do is we want to add our single digits together. We want to add the 5 plus 2. And we'd want our first graders to use whatever strategy they would have used, for instance, in the previous video, to add these two single digit numbers. And adding 5 plus 2, we would start with 5. And in our minds, we can count on 2. So it would be 6, 7. So 12 plus 5 would be equal to 10. And the 5 plus 2 equals 7. So 10 plus 7 would be equal to 17. If you're interested, just like the previous video, here is the complete standard that this video, Adding Within 20, is based upon. Add and subtract within 20, demonstrating fluency for addition and subtraction within 10. Use strategies such as counting on, making 10, for example, 8 plus 6 is equal to 8 plus 2 plus 4 is equal to 10 plus 4 is equal to 14. Decomposing a number leading to a 10, for example, 13 minus 4 is equal to 13 minus 3 minus 1 is equal to 10 minus 1 is equal to 9. Using the relationship between addition and subtraction, for example, knowing that 8 plus 4 is equal to 12, one knows 12 minus 8 is equal to 4. And creating equivalent but easier or known sums. For example, adding 6 plus 7 by creating the known equivalent 6 plus 1 is equal to 12 plus 1 is equal to 13.